Hello, team. Welcome, everyone. My name is Scott, and I'm coming to you live from Wellington, New Zealand. Well, we've made it. We've made it to June, halfway through the year already, and we hope you're safe. So we've chosen to run this meetup virtually this time as well, which is great because it means that we can welcome some international guests, some international speakers this evening to share their stories. So AWS User Group Aotearoa is New Zealand's own user-run and user-focused AWS community. We're here to build the next generation of AWS professionals, be inclusive of everyone, to help career progression and job matchmaking, and to promote excellence in the development of AWS. So whether you're just starting out building your first workloads or you're a seasoned pro, you're always welcome to join this community. We host meetups usually in person in Auckland, in Wellington, and Christchurch. And when it's virtual like this one, we live stream the sessions. We've got a Slack channel that you can join to connect up with other people in the community, share your stories and problems, and people come together to fix them. So jump onto our website and you'll find the invite link for that there. A continued thank you to sponsors Consigna and Datacom. And you would have met the extended Consigna and Datacom. And you would have met the extended Consigna team at our networking drinks in Wellington in May. So thanks for that, team. And we would welcome more sponsors to jump on board as well. We can run different types of events and continue to use our venues. So get in touch with myself through Slack or on LinkedIn if you can help out. Quickly, a few updates from the exec committee. We need speakers. No surprise there. Come and share your experiences from what you've been experimenting with on AWS, or maybe even celebrate the success of a recent project. Whatever it is, we really want to hear about it. Look out for our new website that will be launching very, very soon. And Auckland, so shout out to the physical meetup that they had last week. Well done, all those who are involved in that. Today we've got an exciting lineup once again, kicking off with Mark, who will take us through the latest AWS service and features. This is becoming somewhat of a core session for these virtual meetups, and I know a lot of us appreciate his insights from the latest news. Then we've got Dinesh, Neeta, and Martin beaming their way onto your internets. And these talks are not pre-recorded. These live, and our speakers today have invested their own time into being here and sharing their stories. So thank you very much to all of you. And let's kick it off with Mark.
Hey everybody. So yeah, it's time for top announcements again. I've tried to narrow them down again, but it's a pretty hard thing to do. So we'll kick it off and get into it and see how we go. Tried to sort of group these together a little bit. So some of the latest identity and security updates coming over the last month or so. So now single sign-on has been updated to allow delegated member accounts to actually manage single sign-on. So this is actually a really cool update. You don't now need to hop onto your master account, which is a good practice to not log into there if you don't need to. So this update will allow us to follow that best practice and be able to update SSO from a member account. So that makes good sense. I also found a really good blog on the top right there around how to use AD and extend that into AWS. There's a number of ways we can do that. So using your on-prem AD, you don't necessarily need to use Azure AD to connect into SSO. So that's a really good blog that covers that. So you can jump into look out for that one. We will. I'll put the slide deck into Slack and eventually onto our new website when that goes live. So you'll be able to grab that. The links should work from there. There's been some new updated trusted advisor checks. So for EBS over provisioned and under provisioned volumes, and the same for Lambda functions for memory size. So if they're over allocated or under allocated, under provisioned, then that will be picked up now by trusted advisor. So that will be helpful. In the networking, there's been quite a few updates that have come out recently. So Private Link now supports IPv6. It looks like they're on a splurge of IPv6 updates. So yeah, now Private Link supports IPv6. VPCs now support multiple CIDR blocks for IPv6. Previously it was multiple IPv4, but only one IPv6. So now we can now add up to, I think it's 5 IPv6 CIDR blocks as well. So that's helpful. Multi-account support for Transit Gateway Network Manager. So the Network Manager now supports centralized management and monitoring of the global networks across multiple accounts within your organization. So that will make that into a much more useful manager across multiple accounts. And there's a new update to data sync, which I think is a really good update and a method for using data sync to actually move data between Azure and GCP or Google Cloud Storage endpoints and copying that data into AWS. And that lets you copy directly into S3, EFS, or the FSX family of services, so FSX for Windows and things like that. So that's really handy addition. I think that might be needed for a few customers who are doing multi-cloud. And again, another IPv6 update. RDS will now support IPv6 as well. And an update to Outposts. So S3 on Outposts now supports Private Link for managing buckets and access points. So it's another Private Link update, this time out to Outposts. There's a few updates to AWS Backup this last month or so. So the Audit Manager now adds compliance for hybrid VMware workloads. So if you've got hybrid networks with VMware on-prem or AWS VMware VMC on AWS or on Outposts, you can now pick that up into the Backup Manager, into the Audit Manager. It also adds support for S3 and Storage Gateway into there as well. And they've extended support for Meetup as well. And Private Link support for VMware workloads as well. And for EC2, we now have dedicated hosts are now available in Outposts. So we also have price reduction, on EC2 for SUSE Linux Enterprise versions. We're also announcing general availability for Nitro TPM and UEFI secure boot on EC2. So that will be handy for those that are using secure boot but need that access. There's also a number of new instance types. There's always new instance types. But yeah, certainly something to watch out for. There's some new Graviton instances, some new Intel instances, which are storage, great storage EC2 instances, and some updates to GPU-based ones, so the P4DE instances there as well. Control Tower has a few updates. You can now do one account at a time, updating into Control Tower. So this is really handy. You don't have to do the whole OU. You can now just enroll one account within Control Tower. So that's going to be really helpful to bring in more accounts without having to bring in a whole OU or update a whole OU at once, which is a great benefit. You can also use core accounts that you've already provisioned. So this was in Control Tower. If you needed to create a new Control Tower, it would create new security account and a new logging account. That will now can use your own already existing logging accounts or security accounts. So that's really handy for bringing in and standard landing, an older landing zone into Control Tower. That would be very helpful. And there's one more thing that I wanted to shout out to was the summit. The sessions are still available online, so just jump on there and do a search for it. Register if you haven't already, and you can get all the sessions there for the next couple of months. I think they've made them available. So yeah, jump on into that. And that is me.
Awesome, thanks, Mark. How many summit sessions did you catch? Oh, we lost them. All right. Hey, I really liked the IPv6 theme there, and obviously the price reductions in EC2 were great. And something else I liked was the how you can bring your own organization accounts to Control Tower now. So as part of the core account. So if you've already got a centralized security account for SecOps and auditing, that kind of thing, you can bring that on into your Control Tower core accounts. You don't have to use the one that's provisioned automatically when you create a new Control Tower managed environment. Looks like Mark's headphones might have died, so let's move on to the next speaker we got today, who is Dinesh. Dinesh is going to talk to us about Global Accelerator. So pretty excited to see that. You might just want to jump off mute there.
Thanks, Scott. So just sharing my screen. Just let me know once you see my screen. Just hang on a second. Cool. So you guys can see my full screen. Scott, can you hear me?
We can see your screen, mate.
Awesome. Thank you. So let's get started. Good evening, guys. My name is Dinesh, and I'm working as a regional practice lead at Datacom, and I'm also an AWS APN ambassador. Today, we're going to talk about AWS's Global Accelerator and how we helped our client in reducing the download time using the Global Accelerator. So let's get in. First of all, what exactly is Global Accelerator? So a Global Accelerator is a networking service that improves the performance of your users' traffic by up to 60% using AWS's global network infrastructure. When the internet is congested, AWS Global Accelerator optimizes the path to your application to keep packet loss, jitter, and latency consistently low. Now, let's have a look at some of its features. So it provides you with static publicly routable IP address, which can also be used to create the DNS entries. You can also bring your own IP address, and Global Accelerator also protects you from the DDoS attack. So Global Accelerator is protected by AWS Shield Standard by default, which minimizes application downtime and latency from denial of service attack by using always-on network flow monitoring and automated inline mitigations. Fine-grained traffic control. So Global Accelerator gives you the option to dial up or dial down to a specific AWS region by using traffic dials. Continuous availability monitoring, which is really very critical. So Global Accelerator continuously monitors the health of your application endpoints by using TCP, HTTP, and HTTPS health checks. Right. So on your left-hand side, you see a typical environment where a user is trying to access application inside the AWS. So as you can see, the traffic is going via different hops, which means different ISP providers, and ultimately adds to the latency. But as soon as you have a global accelerator in the middle, and as soon as the user hits the global accelerator, boom, the user is already inside the AWS network. And from there, the AWS global accelerator forwards the traffic to your environment inside AWS. Right, so let's have a look at the problem statement. So before I start, so in a day-to-day life of an AWS consultant, you work on wide varieties of projects. You work on architecting, you work on re-architecting, you work on replatforming, you work on migrations, lift and shift, lift and shine, a lot of options. So in this case, we are simply migrating the infrastructure from on-premises data center to the AWS without touching anything on the application layer. So in short, we were doing the lift and shift. And one component of lift and shift is that you don't touch the application components. You're simply migrating as it is in like-for-like situation. And as far as client's application was concerned, client's application simply provided a portal which was used by end users to download files. These files could be varied from few KBs to few GBs. And regardless of where we're trying to download the file from, the file downloads were always 2 to 3 times slower. So we noticed the slowness only when we were trying to download the bigger files like 2, 5, 10 GBs, and the download speed was continuously taking longer in comparison to their on-premise infrastructure, which naturally wasn't good, and the client wasn't happy. And we wanted to solve this problem one way or the other. So let's have a look at the architecture which we had initially. So due to the confidentiality, I won't be able to show you the exact architecture which we had for the client, but the architecture which is in front of you is pretty much on the same lines. So as you can see, the application, the user is hitting the application load balancer, and then the load balancer is forwarding the traffic to web server, which is sitting inside private subnet. Pretty standard, right? Like no dramas here, nothing, no extra components being used. It's really standard architecture. But still, we were not getting the required performance. The download time was still taking quite long, which wasn't making the client happy. So what we did, we put in a global accelerator in the middle. And as soon as we put the global accelerator in the middle, we could see the download time being reduced, the performance increased, and latency also decreased. So as a result, the client was happy with the performance, and we continued with the project and the migration. So I did some further testing to support the argument. I did a ping test against ALB DNS endpoint. So when I did a ping test, I was getting the average time 31 milliseconds. When I did the same with Global Accelerator endpoint, the average time was 4 milliseconds. So as you can see, the difference between with and without Global Accelerator, 31 milliseconds versus 4 milliseconds. So the difference was quite substantial. I further did some more tests based on some web tools. I used a tool called Pingdom, and I did a test against ALB DNS endpoint. So the load time was 27 milliseconds. And when I did the test with the Global Accelerator, it was 15 milliseconds, almost half. I repeated the test with another tool, and as you can see, all the performance metrics are better when I was using the Global Accelerator. So the result was pretty apparent, and as soon as we put in the Global Accelerator in the middle, it improved the performance, and it helped us in reducing the overall download time. And at the end, if the client is happy, we are happy. Right. So on the left-hand side, I've created a CloudFormation stack, which has got like 2 stacks in it. The first stack basically creates a 3-tier architecture, which involves a VPC application load balancer and Apache web server running on EC2. And the second stack basically creates a global accelerator inside North Virginia, because Global Accelerator is a global service. So you have to create it inside the North Virginia region. And on the right-hand side, I have also created a blog on the same topic, so please feel free to have a look at that. And do not worry, I'll post both the links in our chat for you guys to review. Thank you so much. Please feel free to ask any questions if you have.
Awesome, Dinesh. Hey, I'm looking at the YouTube live chat. No questions in here at the moment, but feel free to jump in that chat as well and answer any questions that come through.
Thank you.
Awesome. Wow. Another great chat. Thank you very much. Next up, we've got Neetu.
Hey, hello everyone.
Whereabouts are you coming to us from?
Yeah, I'm coming. I'm live from India, and it's great to be here. I'll be talking about networking basics. About me, I'm working currently in City as a manager, and I am also a co-organizer of the AWS user group Madurai in India. So that's about me. So let me start with the topic. My screen, you all can view it, right? No problems with that. Scott, hello?
Yep, we can see it.
Is it good? Okay,
yep.
All right, fine. Thank you. Okay. So first topic that I would be talking about is address resolution protocol. That is ARP. This basically, usually when we type it into a browser, we usually type the IP address, right? But behind the scenes, though, in the OSI model, how does the IP address gets translated to the MAC address? I mean, because at the network layer, OSI model, the packets that are being transmitted, they have source IP address and the destination IP address of the machines that are communicating. But what about the layer 2, which is supposed to have the MAC address? Because frames usually use source MAC address and destination MAC addresses. So in this case, I've just taken an example when PC1 and PC2, which are on the same LAN, they have a source IP MAC address on both their ends. And here the ARP, that is the address resolution protocol on PC1, the moment it gets it sees that the layer 3 is ready with the packet, what it would do is basically it would broadcast an all Fs into the LANs, into the LAN, and ask who has the IPs, which is supposed to be the destination IP, which is 161.1.37, and it would ask who has this IP address. So on the other end, the IP address belongs to the so PC2, the ARP running on the PC2 system what it would do is that it would send a message back saying I'm this particular IP address with this, and this is my MAC address. So that's how we get the destination MAC address when we are communicating at this layer. And then a frame is created using the source MAC address, which we already had, and the destination MAC address and the payload from the network layer. A frame is created and given to the next layer, which would be the lowest layer, the physical layer in the model. And this would then be transmitted in the form of electrical or optical signals, depending on what is the medium used. And it would go on to the destination side, wherein there would be similar layers which would decode that information and give the payload back to PC2. So going over to the next topic. This topic is about network translation. This is something which is extensively used in internet gateways and NAT gateways in AWS cloud. So as we see, IPv4 has a limitation of the number of addresses, right? It has around 4 billion addresses, and all of us have lots of devices. Maybe it's PC, or we have our tablets, or multiple PCs, our phones. So everything, if you go to see, based on the population, there won't be even a single IP. There will be less than a single IP address for one person if we go by that way. So, and also there are private and public addresses. So all of the IP addresses that are available in IPv4, they are not public. They cannot directly connect to the internet. So there are private addresses which we are actually using for our home network, right? We are used for our home PCs and all. And there are public addresses that are used by Google or Netflix. So how do we connect, and how do we connect these systems to the internet, or how do we ping, or how do we talk to Google, the Google system, right? Google server. So for that, NATs are come into picture, wherein they help resolve the shortage by basically mapping this private IP addresses to public addresses. How they would do that is in three ways. That is a static NAT, a dynamic NAT, and by port address translation. So let's try to understand what a static NAT is. So in static NATs, let's take this example wherein we have an EC2 instance in AWS, and we have the internet gateway in between, and we have a Linux update server which the EC2 is trying to talk to get Linux updates, right? So here what happens is this is in a private AWS zone, so it won't be able to directly talk to the over the internet to the server. So what it would do is it would send a packet with the source IP and the destination IP to the internet gateway. Now, internet gateway has a NAT table wherein there would be a private IP mentioned and a corresponding public IP to it. This is a one-to-one mapping. So for the private IP of the EC2 instance, we have a public IP, and it would then change this packet to have this source IP mapped as the public IP, and the destination IP would be sent, and then the packet would be sent to the server. Similarly, while responding back, the server would flip these because now the source becomes the destination and destination becomes the source. So it would send back, and as we see, packet P2 that has a destination IP, which is actually the public IP. This also would get come to the internet gateway. Now, how does internet gateway understand where to send this packet to? So for that, it would again refer the NAT table, when it to see that the public IP belongs to this particular EC2 instance, then then it would send it to that change that destination IP on this packet P2 and then send it to the EC2 instance. This is at a low level how it would be happening. So the thing that's important here is that the EC2 instance, the OS on the system doesn't know and is not aware of the public IP. Okay, this public IP handling, because we see when we start a particular EC2 instance, we see that there is a private IP address and there is a public IPv4 address. But the instance is only aware of the private address. The public IP address is something which is taken care of by the internet gateway. Now let's go to the next part, which is dynamic NATs. So in dynamic NATs, what would happen is that there would be a shortage of the number of public addresses. So there are more private addresses and less IPv4 public addresses. So in that case, what would be done is that we would have multiple IPv4 private addresses mapped to a single public address. Okay, so there would be a dynamic mapping based on what is available in the pool, and then it would be dynamically mapped. So it might happen that two PC2 and PC3, right? They are communicating to the same destination, but both are given the same public IP. But in this case, both cannot communicate at the same time. So once PC2 or PC3, anyone who is selected, if PC2 is communicating first using this public IP, it would have to get back the response only then once it's the response is received by PC2, then it would be mapped to PC3 and it can communicate. That's how dynamic NATing works. Going over to port address translation, this is something that is used in the NAT gateway. So how this works is that it uses just not the IPv4 address, but it will also use the ports. So say we have PC1 here on the left-hand side, right-hand side we have the server, and we have the router in between. So what happens is that the source IP address, which is private and has a port assigned to it, there's 1050, and there is a destination IP address which is public and it has a port as well. So when this packet P1 is sent over the route, what it would do is that it would check the NAT table, and there the private IP and port have a corresponding public IP and port attached to it. Put that as the source IP and the source port, and then it would send the packet to the server. And similarly, while responding back, it would again check the NAT table and find the corresponding private address. Here, the thing that's important is that we have only one public IP, which is being assigned to all three in this example, but we have different ports that are assigned. So in that way, it helps us to map multiple addresses to a single public address, but we have a port to differentiate between it. And similarly, we see that on the private IP part, if we see we have two private IPs which have the same port. but we have different public IP ports for them, and that helps in this way. This port address translation achieves is able to overcome the challenges of the shortage of the IPv4 addresses. So okay, so let's understand what a VPC is, which is a virtual private cloud, right? It's like a huge network, okay, in which we can host multiple AWS services, but that happens within, the big network would be further divided into smaller subnets, and there we would be hosting our AWS services. Now, VPC is a regional service, so it spans across a region, across multiple availability zones, and within these availability zones, we would have subnetworks. So in the further slides, I would be talking about how we can design a custom VPC on a high level. Before that, for ease of my understanding, I always try to use kind of a real life example to kind of support a particular concept. So for me, I think of VPC as a hotel and subnets as smaller rooms each room within that hotel, okay, which has its own amenities. Everything is there within the room itself. And to enter the hotel, you need to have a reservation, plus you need to have a valid ID proof. So that way, your anything that comes in is validated, and that's how your internet gateway and your VPC router works. So I usually try to kind of make an analogy between the two. Let's go to the next slide. Okay. So as I said, while designing a custom VPC, what all things do we take into consideration? What are the best practices? First of all, to understand what CIDR range a particular VPC needs to have, we have to understand what would be the IPs. Go to the level. We have to use a bottom-up approach. So we have subnets. Okay, so how many IP addresses or how many hosts do we want to have in a particular subnet, and how many subnets would be needed? Based on that information, we can decide, how do you want to divide your network is what would decide how big the network is going to be, right? So that's how we decide the VPC CIDR. And then we should not be having overlapping or duplicate ranges. It should not be happening that two subnets are in an overlapping CIDR range, okay? Both have to have independent CIDR ranges, and the addresses should not collide with the collision of addresses. Then we have to avoid ranges which are used by, say, suppose you have a client coming in who has multiple offices and who has other vendors, cloud solutions working on their system. So how do you avoid these ranges? So first thing is you have to avoid such ranges wherein they would be using, say, the other vendors' clouds. So you have Azure pilot running somewhere. So you have to avoid that. You avoid the on-premises IP range. Then if there are other VPCs that they have in their system, that has to be avoided in their cloud. And we also need to avoid the AWS default VPC, which is given by AWS. Next thing is we have to kind of have an amount of resiliency, right? The VPC is a regional service, so we have to span it across our customers we would also have to span across multiple AZs to have more resiliency, so that we can quickly jump back from failures. Then next is we should always have in mind a certain buffer, because it might happen that the workload for the client would grow, their business grows. So we should always have a buffer in mind while designing, so that we can always handle such increase in growth. Okay, so these are the standard VPC prefixes that are provided by AWS. So the minimum is /28, which is around 16 IPs. Even though we say it is 16 IP, we need to remember that around 4 or 5 of those addresses would be utilized by, say, the broadcast address, and the first address won't be used. The second would be the DNS address. So these things would occupy certain IP addresses, like around 5, say. So we only have 11 IPs. Similarly, we think of the growth of the network, we need to understand that if we choose a particular subnet size, it is going to have a certain number of IP addresses lesser than what we plan for. And the maximum IP, maximum range in AWS standard VPC would be /16. Okay, so this is kind of a table of what the sizes are allowed. So micro is around /24 net mask, has around 27 hosts per subnet and 216 IPs. Similarly, it has 8 subnets, and the extra large one, which has /16, has a subnet size of /20 and 4091 hosts and these many IPs. Okay, 16 subnets. Okay, let's go to the next slide. So I just have a hypothetical. I've just taken a hypothetical situation here to just kind of help how we can plan the VPC structure. So there's an XYZ company which is based out of US who wants to do cloud. They have an on-premise range that I've given. They have 2 offices, one in India and one in Wellington, and those IPs are also mentioned. So once we think of designing the AWS VPC, we'll have to first of all avoid all these ranges. Okay, be in a range which will not collide with these. So I would, for my ease of understanding, have a class A network, okay, which starts with 10 dot, and I start with 10.32.0.0/16. So the points that we remember here, when we select a particular range, whether it is class A or class B or class C, is that we have to avoid common ranges. Say if I say 10.x, it starts from 10.0, but it might happen that many people use the similar kind of range, right? 10.0, 10.1. So we avoid that. So around 10, I would avoid and take up anything after that. Now I'm taking as 10.32.0.0. I would plan for at least 2+ networks. As we said, we have to have buffer. So 2+ networks per VPC per account, and around 3 AZs for high availability. Now, as we know that different regions have like around starting from 3, they would have 5 or 6, as 6 in North Virginia. So for my understanding, I would take 3 AZs. Okay, and now we say we have 3 regions, that is US, India, and New Zealand. So 3 regions into 2 networks each, say 6 networks, and for 3 accounts, it would be 3 accounts into 6 networks would be 18 networks totally. Okay, so here, people who are already working, they might think that it's too big of a assumption made, but let's assume the worst. Okay. So how do we design the VPC structure, right? As I said, I try to make analogies. Here is a pizza, a full pizza, which is a /16 VPC network. When we divide that pizza into 2, that becomes a /17 network of 2 subnets each. And when we divide it further into 2 as well, 4, that 4 subnets would become a /18 network. So that's how I understand when I divide it, how it is gonna increase. /16 divided by 2, divided twice would give me /17. Divided 4 times would be given /8. 8 would given /19 network, and /20 would give me a 16 subnets, which we saw in the earlier slides, that how the AWS sizing for different small, micro, and these VPCs are, right? So that's how it's derived from. So when you say /16 network and you want like 16 subnets, you have to go 4 paces ahead. /16 plus 4 is /20 would give you 16 subnets. Similarly, /17, if you want 16 subnets out of that, so plus 4 /21 would be the CIDR range of the subnet. Okay, so let's go with a bottoms-up approach. As I said, let's start with one VPC. Okay, so one VPC, I say I have multiple tiers. I have a load balance. The client who has come to me has a load balancing tier. He has it has a application tier, DB tier, and a buffer. Just for the business's growth, I am taking into consideration. Then there are 3 AZs, AZ A, B, and C. Now I have taken the range, VPC range is 10.32.0.0/16. Now, when I see this structure, and within each AZ, I want to have a subnet which would take care of each of my tiers, then I'll have 12 subnets here. And how do I divide into 12? So I have 8 subnets by /19 network. And further, if I take 2 of those pizza slices and divide it into 2 again, that 4 subnets would become a C network. So 8 plus 4, 12 subnets, and these 2 would be the ranges. So for 3 regions, I would say US, India, and New Zealand region, I would take 16 kind of VPC CIDR ranges. So 16/16 networks. So 10.32 to 10 for US, 10.48 to 10.63 for India, and 10.64 to 10.79 for New Zealand. And these would be again for, these would be divided into two accounts, because two accounts can host, each of those accounts could host multiple regions, right? So I'll have half of those ranges, that's 8 in each of those accounts, 8 networks in each of those accounts. Now, moving on, I'll just show how to create a custom VPC. Just a second. So here in my AWS console, I'm creating giving a block of, as I said, I would start from 10.32. I would give a IPv6 CIDR block as well, because now there's provision for IPv CIDR blocks all the time. So let me go with an Amazon provided CIDR block. I would go with the network border group as US East 1. I would go with default tenancy, because if I select dedicated, then all my resources would be deployed on a dedicated hardware, which I don't want, because that comes with an premium cost. I'll create a VPC here. Create a VPC is fairly very good, but then to the architecture, it would kind of become more complex. But I don't want to go into all of that because we are short of time. Okay. So we check whether that there is a DNS resolution, so that we can talk to the DNS addresses of that. Just a second, sorry. Yeah, we can also talk to each of the resources, because this is some cascade from the VP to the individual resources. I'll enable the DNS host names, just so that every resource would have a DNS host name as well. So yeah, that's from me. I think, yeah, I'm done with my presentation, and thank you. And any questions, I'm open for.
Thank you very much, Neetu. Yeah, jump on to the YouTube live chat, and if there's any questions coming through in there,
sure,
then you're welcome to answer those. Hey, I really liked your analogy about the VPCs being a hotel and the subnets are a room inside that. That was really cool. I don't know about you. It's probably early. It's early in the morning in India, but yeah, talking about pizzas has made me pretty hungry.
Yes. Thanks. Yeah.
Thanks very much. Up next, I think we've got Martin, but we're just double checking if he's connected, or we might have to just pause a bit. I think he might have dropped off.
Hello.
Oh, here he is.
So just as a camera.
Where are you beaming in from today?
From today, that's a good question. I'm back from kind of a little trip, more or less. I'm now in Germany. I'm very happy to be back in Germany. So it's quite early for me. So I didn't ever made a presentation that early. So, but I'm like an early bird. So sorry if I kind of, sorry in advance if I kind of misbehave, but I will give my best. So
it's okay. I hope you've got enough coffee with you.
Awesome. Thank you so much for this opportunity. It's really great to speak even at this distance. Okay. I will share my screen. Thank you for reminding me. So can you see my screen?
Yep.
Awesome. That's the wrong button. Sorry. This one here, I guess. Cool. Yeah, the subject today I would like to speak about is cck-dia and how you can create beautiful diagrams out of CDK code. So short about me. Who am I? I'm Martin Müller. I'm from Germany. I am an AWS solution architect. and yeah, I work with AWS since like 2017. When I was based in UK, so I was one of the first people to like jump on those AWS tasks, and there was a lot of fun, and kind of started to get an affection from DevOps to DevOps, and really love to work with AWS CDK and DevOps topics, pipelines, building pipelines, monitoring, and so on. And yeah, and as an update, I joined Roles quite recently in June. I'm working for Monada.co, and yeah, this is an exciting startup. We are planning to reinvent kind of the cloud and how developers are working with it. So please follow me on that. So I keep regularly updates on that and blog posts and tweets. And I guess some of you are aware of that. And yeah, it's really an exciting time. And yeah, and back to my presentation. So the short agenda, I have like 25 minutes and I try to keep them yeah, as good as possible. I will talk first about in general about diagrams and how I usually use them to make life easier for me and for my clients. And then I go more into detail about the cck-dia library, later how you can integrate it in your project, what is planned in future with this library, and at the end I give a little kind of comparison between that and some other tools where you can like draw diagrams with AWS basically. Okay. Yeah, I don't know how exactly. If you have any questions, feel free to interrupt. I don't know if that's. I don't think it's possible. I think if it's possible, feel free to interrupt me, and I can answer questions. I'm happy to do that. So yeah, usually for me, like kind of diagrams are very important. They are helping me to kind of design. One point to design an AWS solution I'm building. Or to understand one, when I see a diagram, it helps me a lot to understand it, to make it much more easy. And this kind of makes sense because we humans are made for visualization, yeah, and colors and all that. So it's a really nice abstraction. And as a developer, I love abstractions. Yeah, so that's why I love CDK as well. And yeah, building diagrams is in its own way an abstraction. And yeah, you can see here one example, one of my CDK constructs, and I think it's really like kind of give you a quick grasp what it intends to do without going here into details. But yeah, if you want to know more details about CDK Prowler, I'm happy to provide that to you after, or you can look at my internet site, martinmuller.dev. The tool of my choice usually is Draw.io, and I bet from a lot of you prefer that too when designing diagrams. But of course, there are a lot of other nice tools which you can use as well. So this is just my little preparation. I guess it was like one of the first, and I stuck with it. And I really like the search function there. Yeah, so and then you just like type in Lambda, and it offers you a bunch of icons. But I guess the other can do similar other tools like that. And yeah, so, and as well, if you are using the VS Code as your IDE, there's a good tip to use the extension there, because then you'd not even need to leave your IDE. That's very great. You don't even need to go to the browser here. So it makes developing even faster, let's say, and that's really cool. Yeah, so okay, so drawing those diagrams, it's fun and it's special for designing, but if you like need to keep it up to date, it's kind of getting annoying. when you are more like a person perhaps like me, bottom up, you are starting your first approach, and then you change something, and then you always need to adjust those changes in the diagrams, and this can be a little bit annoying, at least for me. So I mean, how cool would it be if we just automate that? So, and this is really what cck-dia is for. Yeah, so it just generates a diagram out of your CDK code. yeah, the Tom Pistacia, he he is not Tom. I think it is the name. Okay, there's a really nice library out there, the cck-dia, which makes that possible. So it helps you to create those beautiful diagrams. Like one example you see here on the right. This is from my Prowler construct before. So this on the right, this was generated automatically out of the code. I didn't need to do basically anything. So that's very powerful, and it's still quite, as you can understand, still quite good what is intended to do. And yeah, it's based on Node.js, so keep that in mind. If you're like more in the Python environment, perhaps, or in another one, yeah, you need to regard that as you need a Node.js environment. Okay, so yeah, how you can integrate that into your project? I think this is yeah, basically like almost every npm package. Let's say you are just installing the module, preferable in your developer scope, as you can see here. And then you can create a script. And if you are already in Node, you can use the Node, the package.json scripts section for that, and create your little script here. And as you can see, like in the first script here, what you need to do first is you need to synthesize the CDK code. I assume that everyone is kind of more or less familiar with CDK. So in CDK, you have this synthesize step where you synthesize your programming code, let's be it in TypeScript, into CloudFormation, and this is called synth. And you need to do this first, and then you just can run cck-dia. It will generate the diagrams, and if you then want, you can move this diagram picture to your folder of choice. So this is how normally I do it. As you can see in the last part, the move diagram I move it to the folder diagrams, and kind of rename it here as well to dashboard png. So it's a fairly simple comment in my opinion. And if you as well want to split up your CDK stacks in multiple diagrams, you can do this fairly easy as well, as the cck-dia command has a parameter here for you can specify the CDK stack names just, and you see then you are just stack 1 and stack 2, perhaps your dashboard and basically the same, and you then just run like the other stacks, and then you have it kind of separated in multiple images. And yeah, that's really comfortable in my opinion. So yeah, where will the journey go with cck-dia? So the author Tom Roshko, he looks for help. There are a lot of nice features planned, so there are a lot of requests, and he would really love if he could get some help, like with a pull request, yeah, to help him out there, or maybe answering questions. I think totally worth it to help him out there, and there are nice feature planned, like when you saw this like those maybe perhaps like arrows directions, yeah, how you could do that, and this would be a very nice feature too. I mean, I like it already how it is out of the box, but why not providing some more features? And I see I'm really good on time, so I will do this here too. So I made a little comparison with some other tools which are suitable for drawing diagrams. So it is rather a small comparison. I guess you could have spent some more time, but here I give my explanation where I think. So I compare cck-dia with cin-diagram versus the native kind of template visualizer from the AWS console. I don't know if everyone ever used it, but AWS console, they have their own template visualization there. So yeah, I think yeah, cin-diagram is a Node.js tool as well, and it generates pretty similar basically to cck-dia. So, but it's more like you have to provide it your CloudFormation template and not the CDK code or the CDK compilings, let's say. And yeah, the CloudFormation template is native to AWS. And in my summary, I think that the winner is definitely cck-dia, because what is really cool about it, and the other don't do that, in cck-dia, and here it gets a little bit complex if you're not too much into CDK, because the CDK has the uses the composer pattern, so to create your CDK stacks. So you have like level 1, which is basically just CloudFormation resources. And then over on top of that, you have level 2, which uses just is an aggregation of level 1s, and so, and what CDK does, dia does very nice. It just shows the important resource from level 2. Yeah. So let's maybe, what is a good example? Yeah, maybe a Lambda. A Lambda usually has a role on policies, but I'm not interested in the visualization of the role and the policies. I'm only interested in this little Lambda symbol. And this so far can only do cck-dia. Yeah, the other one above, they would render, let's say, all 3 resources. And this is a very nice abstraction, and that makes it, in my opinion, the winner. So yeah, that's it. Any questions?
Let's pop up the live chat. No question at the moment, but hey, that was amazing, Martin. That was cool. I'm gonna have to do a lot of trying out myself on that one. Yeah, thanks for coming and sharing, and that goes for all of the speakers today. They were amazing. 2 international speakers. So if you're out there in the world on the internets watching this live stream, or maybe you're watching the video again after the fact, hey, come and join our Slack and come and talk and share your experiences. Maybe you're doing things differently overseas than what we do here in New Zealand. Maybe we could learn a thing from you. But thanks for coming and spending the time with us today, and we'll see you at the next one.